So hello everyone, today I'm going to talk about the physics buoyancy project. So our experiment question is how much time does different values of coins from different countries need to sink? We want to investigate the topic because there are many different kinds of money all around the world, and we want to test if the weight of the money affects buoyancy or not. Both can float on water because of buoyancy, and buoyancy is an ability of something to float on water or other. What is the relationship between buoyancy and weight? And if the weight changes, what will happen to buoyancy? And now I'm going to talk about some of the keywords. We have 5, and I'm going to talk about 4 of the keywords. The first keyword is buoyancy. Buoyancy is the ability of something to float on water or any other fluid. Second word is density. Density is the quantity of atoms in a given area. And now we're going to show you our video for our experiment. So this is the end of our video, of a very short video of the experiment. Okay, so now I'm going to talk about our first result, which is a table, and then the table shows each of the coins' masses. So in this table, we can see that the Taiwanese $1 is the lightest and the Taiwanese $50 is the heaviest. And in the second table, it shows all of our results for the experiments after we tested them. There are 3 trials, and the last one is the average. And there are two numbers that are shown in red because it is quite a bit different to the other 2 trials. And for each of the trials, either the coin was somehow a bit stuck to the side of the tank and then sinks into the bottom, or when we started the timer, our hands didn't let go fully. Either one. And this is our first graph, which is to the first table, which is the mass. It makes you see clearer. So the RMB $1 and the Singapore $1 is the same, has equal mass, and the Taiwanese $5 and the Singapore $20 only has 0.2 difference of the mass. And the last graph, which is also the most important one, which is the 3 trials, and the orange one is trial 1 and the yellow one is trial 2, and trial 3 is the green one. As you can see to the graph, Taiwanese $5 and which is green, so its trial 3 has the less. So it means that it sinks the fastest, and the one that sinks the slowest is the $50 trial 3, Taiwanese $50. And this one is the average of the 3 trials, and there are numbers of the average on top. So we can see that Taiwanese $10, which is 0.6 for the average, sinks the fastest, and Taiwanese $1, which is 0.84 seconds, sinks the slowest. So according to the last graph, which shows the average of the 3 trials, we can tell that the average time of the Singapore $1 while sinking is the fastest. However, it is not the lightest. Also, according to the graph, the average time of the Taiwanese $1 and RMB $1 while sinking is the slowest. But the Taiwanese $1 is lighter than the RMB $1. As a result, we suggest that the mass doesn't have anything to do with the sinking speed. And also, we could see that the three closest average sinking speed is Taiwanese $10, RMB $5, Singapore $20. Although we didn't measure the density, but we could infer that the density of these three coins are somewhat similar to each other. And here's our conclusion. And also, we said that our hypothesis is if the weight increases, the time of the coin sinking down will be faster. So we can tell that our hypothesis is rejected. This is shown because even though the time isn't as what we expected, we found out that the mass doesn't affect the sinking speed. It is the density and the shape of the object that really matters. And this support goes against our hypothesis. For the evaluation and our problems with the experiment. So if we can do this experiment again, we can make the time that we press the start button and the time we put the coin into the water more accurate, so it could be the same. And also, if we could do the experiment again, we could do more trials so that our results and conclusions will be more accurate. So thank you for listening to my presentation.